So why the hat? Well, you guys know it's hunting season here in New Hampshire and you can't be too careful. So I just wear it all the time during this season. So last time I told you that we were taking a little detour into Power Supplyville, and this caused a lot of controversy with guys thinking that they could use that little module, that little inverter module, to power up things like their ARC-V or maybe their little QRP transmitter for the field. They like the idea of using a drone battery to power a DC to DC high voltage converter and having that power your tube type QRP equipment. Remember, this is retro QRP. That's really what we're talking about here. Hillbilly QRP using tubes. This is going to be another power supply type video before we finally get to the field with this transmitter and do something with it. So stand by and be patient. We have some surprises with the inverter that we're going to have to overcome, but I guess we'll call this DC to DC converter for tubes part 2. So here's the power situation, and this is kind of a WAG, and I hope it works. The high voltage, of course, is based on the drone battery, which is a 24 watt-hour battery. And the filaments I'm going to do with a pair of D-cells. I'll get one of those plastic D-cell holders and stuff that up in the corner. And hopefully everything fits in there with these guys tucked away. I know it looks pretty small. In that box will be the battery, the AC inverter, and the rectifier, filtering, and any regulation I might add. It's all going to go in that little box. So that's a very tiny power supply. In fact, it's smaller than most power supplies used with solid-state QRP rigs. But I won't expect to operate as long, that's for sure. Fortunately, this is CW. When I turn the unit on, only the filaments will be lit. When I go to transmit, the actual inverter will be started up, and only then, when I press the key, do I actually draw the 1 to 2 amps. I'm hoping this will last long enough to make a few QSOs in portable operation. We'll see. Now if it doesn't, then I have to abandon this battery idea and make the battery external. But I can do that also. So this is my attempt at the power supply situation for the 1930s style portable transmitter. Okay, so the proof is in the pudding, of course, and I do want to try to power up a command set with the little power supply before we go further. Now this voltage will be just a touch high, around 275 volts at 50 or 60 mils, so I think that'll be okay for the ARC-V. A little higher than I like to run them. This has been rewired to 12 volts, so the battery will light the filaments, no problem. So the last connection to be made is the connection from the plus on the input of the inverter to the plus from the battery, and that should put high voltage on the receiver. Of course, this is going to be a 12 volt input, so let's see if I can find a jumper, and we'll try to make that connection and see what happens. Okay, a little hard to follow, but I have the B plus going to the plus part of the ARC-V, and the ground going to the ground terminal. This ARC-V, of course, is wired for 12 volts. So the filament will directly connect to the same positive input as the input of the inverter, and this is the main power off the battery that's both going to light the filament on the white lead and go into the inverter to make the high voltage for the receiver. So let's hook it up. Okay, there's a fault, and the reason there's a fault is it's detecting a direct short between the ground on the input and the output. It does not tolerate having a double ground. In other words, if there is a ground that is at a certain impedance on either of the AC output leads, it detects it as a fault and sends that 4 beep signal. So the protection feature in this particular power supply prevents me from both lighting up the filaments, one side of them being grounded, and putting out the high voltage, one side being grounded. The only way to actually light up the receiver and to supply high voltage with this particular power supply would be to add an isolation transformer at the output of the power supply that breaks that ground. kind of defeating the purpose when I have to add a transformer to the output of the inverter to make it work. I could also cut the filaments loose and run them all isolated from ground, which probably is not suggested. So we have a kind of a forbidden situation here with this power supply because of its advanced protection circuit. Now this this problem doesn't exist in my transmitter because I specifically ask for isolation between the filament and the high voltage because that's how I key the radio. So I'm using a separate power supply in the form of a couple of D batteries to light the filaments, and I'm grounding that whole thing, and that doesn't violate the high voltage power supply. So this is a big limitation with this particular approach, and this is going to get people in trouble. This is an unforeseen unknown, an unknown unknown. Okay, here is the inverter running the command set.
Certain signals, certain sounds, certain things that you do, they know that that's just about
things up, changes, yada yada. So anyway, running it's the Barker Williamson 51 SB, the sideband.
Pretty quiet. We have another solution that someone has suggested. It's a step-up converter that Amazon sells, another Amazon product, which should solve this problem. So we can get into that. I think we reached the limitation as a general purpose power supply because of this ground fault problem. So there's a lesson learned here. I just assumed it was going to work provided the high voltage. This is not going to work as a general purpose power supply for most of your ideas that you have going around in your head. Now, will all inverters have this issue? I don't know. It's a kind of a ground fault type thing. I would assume that most of them would have something like this. But I know that this one is actually touted as having many, many safety features built into it. So maybe this is one of those clever safety features that maybe doesn't occur in other types of inverters. So here we have the high voltage DC to DC converter module. Just got this from Amazon, and this guy has a potentiometer, as you can see right here. It allows you to adjust the output voltage to what you want, so I should be able to adjust this with a 12 volt input to the 200 volts that I want. No fuss. Now it may need a little extra filtering, but you could agree that this is a less costly and less work than I was doing with the inverter. So don't mean to change horses in the middle of the stream. Let's quickly try this on the command set. See if we can get this to work with the command set first. If we could get that to work with the command set, I think that'd be a good first step. Okay, so far very impressed with this little thing. Let's see, I've got it programmed for around 200 volts. Let's see what we got. 205 volts. And let's see what our input voltage is. 13, let's bring it down a little. Let's bring her down to, yeah, just about 12 volts, 11.9. Let's see what our output looks like now. Same thing, 204 volts. That's what we're going to try to fire up the command set receiver with. This is really cute. I have the small voltage converter attached to the ARC-V, a single battery solution. The battery lights the filaments and also powers the DC to DC converter. The converter has a common ground between the two, so there's no problem. This is a noisier converter than the other one. I do have a 0.1 capacitor across the output, as well as a 220 ohm resistor with 100 microfarads on the other side of it as a low-pass filter. So let's see what we got here. Just attach the battery. The green light came on. That's good. It's about 9 o'clock p.m. 75 meter band.
Wow, that's incredible. Our air's kind of high. You know, we get some winds. You know they're going to have some crosswinds. That'd be a challenge to land up there.
Seems to be working.
You've done a few landings there. Okay, maybe getting the easy meal. Right. Yeah. Who is it coming?
Let's see if I can hear CHU. Let's go down to 3.3. Yeah, that's working. Okay. Not bad. I think I would house this in a metal case in the back of the ARC-V, and I'd probably use filter feed-throughs. This does put out some RF hash compared to the other one, but it is working. So the way that these drone batteries work, you have a charging port and then you have the output terminals. This is the charger, and this is not a really fast charger, but it's capable of charging this battery within about an hour. And you simply plug it into the appropriate port. Some of the batteries take 4 and some take 3. This one takes 4. So the idea is I want to be able to use this charger to charge the battery when it's inside the transmitter's case. That means I have to have a charging port on the outside of the transmitter. So I have one. Okay, let me try to show you that. It's on the front here with 4 terminals. And I was able to buy some extensions for the charger. Okay, these are extender cables. The 4-port. Here it is. Okay, I've got a 4-port here. Basically, we plug that in. Okay, and now you can charge the battery through this remote extension. So I cut one of those extensions, and half of it went to this input port. That's going to attach to the charger like so. Okay, so I can externally charge. And then on the inside, I had to extend out from that back of that connector to another connector that goes into the actual battery box, which will also hold the high voltage. So now here's the other side of that cable. So I've sacrificed one cable to be able to charge from the external world and not have to take the whole thing apart and change batteries. Now the D cells that are in there will last a lot longer. I'll have a double pack D cell, 3 volts, and occasionally we will have to take it out of the case and replace those D cells. But I just wanted to show you my idea. That's the start of the internal power supply on the transmitter. So you guys kind of have to forgive me that I had to devote an entire second video to this high voltage power supply converter stuff. But I think it will pay off from what we've learned let's take a look at how I'm going to mount it in the case. Fortunately, this box happens to have some kept nuts that are actually swaged right into the case, so those are blind threaded holes. So all I have to do is drill a couple of holes in the back of the set, and this thing will be mounted in there either in this orientation or probably on the roof. And there will be a couple screws up there in the back that will, you just have to loosen them up and the box can come right out. So no nuts or anything or hardware to come loose. And that's how I will service the module. And there will be an umbilical that comes off here that you will disconnect. I probably should have had a different style of socket, maybe an octal, where I had enough leads to do everything on one, but I wasn't thinking that far ahead. Instead, I mounted a connector that didn't quite have enough, but that should be an octal and it would take care of everything, but who cares at this point. And again, a D-cell holder on the side over there to light the filaments separately. This battery will just sit in there, something like this, and the whole thing is complete. Sorry I didn't get it into the case and the transmitter working on this video, but the next video the transmitter is going to be done and we're going to be ready to go to the field.